welcome to the broadcast, everybody. So my name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know what we do, we are all about bringing conservation, adventure, and science into classrooms and homes over the summer for people all around the world. We do about 500 broadcasts every single year featuring the elite of science and exploration on this planet. And frankly, there is no better kind of story than the one we are having the chance to tell today. And you guys responded well to that. It's summer. I know people are off on vacations doing a lot of cool stuff, but we still had groups from 10 US states, 3 Canadian provinces, and South Africa to boot, all registering for today's program. So welcome, bravo, thank you for joining us live or after the fact for a very exciting session. Now, as many of you may have seen over the summer, we have the James Webb Space Telescope, which has now gone out and is sort of replacing Hubble, so to speak, as this iconic instrument for exploring the cosmos. Well, while this has been happening in the stars, there has been another iconic research vessel or research machine that has been sort of coming up with the coolest, most amazing discoveries over the last several decades, and that is Alvin. Now, as a boy, I was so inspired by Alvin and the hydrothermal vents it helped discover, the Titanic wreck that it explored, the mid-ocean ridges, these incredible mountain ranges, and so much more. And so today, I am personally and professionally thrilled to be joined by Ken Rubin, a scientist on board the Atlantis research vessel, and Karen Romano-Young, who's done amazing work with her I Was a Kid series in featuring scientists like Ken to talk about what's going on their expedition currently in the Caribbean. So without further ado, I'm going to bring them in to say a huge hello and welcome to the broadcast. Karen and Ken, thank you so much for joining us today.
Thanks for having us. Hello, everyone.
Yeah, so we've got groups. We've got Mr. Laveau's class with us, joining us in North Palm Beach on literally their first day of school today. They're canceling the lesson just to come and hang out with us, which is pretty exciting. We've got a class at the Phoenix School, Miss Dodson, and so many more. So it's so nice to see you guys in the ship. So Ken, can you tell me a little bit about what this expedition is all about and where you guys are off to and what's going on?
Yeah, so we're on the research vessel Atlantis. I'm going to show you a picture of it here in the dock in Puerto Rico, which is where we left about a week ago. And the purpose of this expedition is to take the submarine, the Alvin submarine, and test it out for scientific operations after it had been out of the water and being modified to be able to dive almost twice as deep as it used to be able to dive. So now it can go 6,500 meters, which is about 20,000 feet under the sea surface. And the whole purpose of this expedition has been to take it to a couple of different locations, one in Puerto Rico, and now we are just to the west of the Cayman Islands, to very deep features that we can study with the submarine to look at the biology and the geology and the various other features of the water that we find in these areas. And right now, we're basically still verifying that everything on the sub works to the expectations of the various types of scientists who will be using this vehicle in the coming years. And we're really excited because Alvin has had a long history, many, many decades of use in the oceans. It is occasionally updated and modified to add new capabilities. And besides the deep diving capabilities, the sub has a lot of other great systems on it, you know, the most modern and high-tech video systems, camera, lighting systems, propulsion systems, etc., that allow us to do our work deep in the ocean.
Very, very cool. And so, again, 6,500 meters is this huge number. And for our American audiences, I want to stress that if you go for a 4-mile walk anytime during your week or in the not too distant future, that is how far this is down beneath the surface of the waves. And so it's taller, it's deeper than Mount Kilimanjaro is tall, sort of this iconic mountain that sort of looms large in the minds of Africans and tourists alike. And so with this capability, this capacity to go so deep and all these new cool tech toys, what is the aim? Are there specific places that you're looking to go once you've had this test verification expedition, or are there things that you're looking for that this new depth capability would allow you to explore?
Yeah, so the way we use the submarine across the United States research community involves people with different aims and goals. One of the goals is to study the biology in the deepest parts of the ocean and to see what organisms live there, what their strategies for life are, what foods they live on, etc. My personal focus of my research involves submarine volcanoes. And so with this new deeper capability, it allows us to investigate volcanoes in a much greater part of the oceans than we could previously. And one little tidbit I like to remind people of is that most of the volcanoes on the planet are actually in the oceans. Even though we know about volcanoes on land because they're easy to observe, there are many more volcanoes in the ocean, and we don't even really know how many of them are active, how frequently they erupt, and what kinds of materials they erupt. We have some ideas, but having a vehicle like this allows us to explore more areas, to go and visit these places in person, to take samples of the rocks there, and then to also look at the types of phenomena that happen at volcanoes involving what we call geothermal systems or hydrothermal systems, where heat underneath the volcano heats up water that emits onto the surface and supports really unique ecosystems. So there's a direct link between deep sea biology and the volcanism that a vehicle like Alvin, which is what you're looking at on the screen right now, I took this picture just a couple days ago here on the ship, what it can do and bring to us as scientists.
It was the Deep Blue. It was the Blue Planet 2 Deep Ocean episode that I still think is my favorite individual broadcast of natural history ever taken, and it's talking about and showcasing some of these ecosystems you're explaining, and it's just such a magical place and such a unique place on this planet. Now, you talked about that it's a human or people go in the submarine to go down, and this is, I think, very important for people to recognize that we see that there's a lot of robots and remotely operated vehicles that do a lot of exploration in the deep ocean and again in space. But what is that? What is the benefit of having someone go down? And Michael wants to ask if you've been down on it yet on this expedition, Ken. Personally, I'm curious.
I have been down on this expedition. I went down a couple days ago, and I'm preparing to go down again tomorrow. We're picking a particularly deep site, more than 6 kilometers down. I will tell you that there are different tools that we use in the deep sea for exploration. And one of the things that the submarine that we can, that have humans inside is best at is exploration. When we have a remotely operated vehicle that is connected to the ship by a long cable, there are certain limitations because we have that cable. Places we can drive, places we can't drive, how far we can move, how fast we can move. It's really difficult to sort of turn around and backtrack one step. The trade-off, of course, is when you have a cable connecting your vehicle to the ship, you have almost infinite power. We can run all sorts of lights and instruments. So in a submersible like Alvin, where we're not connected to the ship, we can drive wherever we want, but we have to be really careful about how we do our work to make sure we don't consume all of the power that's in the battery packs on the vehicle before we meet all of our dive objectives. So as I say, there are different trade-offs, and Alvin in particular is very good for exploration. And these are just some other pictures of Alvin as it's placed into the ocean and deployed. Now, let me just show you a couple of pictures of what it looks like on the inside. This is me from a few years ago in Alvin. This is a fisheye lens, so it's a wide angle view of what is actually a pretty small little space. You can see in the upper right corner, there's 3 of us in the sub. There's always a pilot and 2 observers, and the pilot does most of the real work. They're controlling the vehicle, they're driving it and keeping the life support systems functioning. They're doing all of the manipulation for sampling operations using robotic arms, for instance, and grabbing things and putting them into the vehicle's sample containers. And the 2 observers, the scientists, are basically making observations, recording things on computers. We have iPads that allow us to control software that speaks to all the camera systems. We type notes into the iPad, and everything gets keyed together so that when we come back to the surface, we have little video clips, we have photographs, and we have the observations that we're making all typed in using descriptive language that allows us to make the most out of these dives, because then we can relive the dive by looking at the video, looking at the navigational information, which tells us where the submarine is at any given time, and put together the narrative of what's on the seafloor, what's the biology, what's the geology, water samples that we took, etc.
Yeah. I mean, honestly, professional detachment is out the window. I'm just like, my face hurts from smiling talking about all this with you, Ken. I do want to stress for our folks at home, if you want to see like the ultimate website of this expedition, all the great stuff that's going on, the sort of unwieldy URL has been below on the bottom of the screen now. And so NDSF stands for the National Deep Submergence Facility. If you want to check out that website, it's really, really fantastic stuff. And WHOI is our Woods Hole Oceanographic Institute, the iconic research lab for ocean research on this planet. So many great programs we've had the chance to partner with them on. And so I hope people get that chance, as well as, and you shared this earlier too, the hashtag Alvin6500 reflecting this expedition if people want to check it out on social media. I do have a quick question for you, Ken, before you tell us about these other deep submergence tools. And again, this comes from YouTube. With the changes to the submersible, is there a bigger space in the bubble for people to be down there with you now, or is it the same, sort of a little bit constraining?
It's still constraining, but it is a little bit bigger. So it's a 7-foot sphere. So if you imagine a sphere with a diameter of 7 feet, and when you're in the vehicle, basically the back third of that sphere is filled up with equipment and oxygen tanks and gas masks in case there's a fire. So we're basically sitting in you could draw a circle on the ground that's 7 feet in diameter, chop about a third of it off, and have 3 people sitting there. The difference between the submarine now and how it was before the retrofit is that there's more modern equipment in the vehicle. There's a lot of boxes and electronical controls, recording devices, computers. All of that stuff is a little bit smaller than it used to be. So now when we sit in the sub, we don't have to kind of cramp down and fit into a tiny little space. We can sit up. We have little windows we can look at. We have computer monitors we can look at. We like to encourage observers to spend most of their time looking out the window, because that's the real benefit of being there, seeing with your own eyes and getting the depth perception that comes from having human eyes on the seabed. So, it is tight. We sit cross-legged in a small space, 3 people, but it is more comfortable than it used to be, a little bit anyway.
Very nice. By the way, I do want to note that you talked about observers being in there, and we've got this chat going on with the Woods Hole team. So thank you very much for joining in the YouTube chat about taking artists down there, all these different perspectives. Again, scientists will be your chief people that you want to take down for their ability to observe, their knowledge of these ecosystems and geology and whatnot. But it's nice to hear that, like some of the work that's done in Antarctica, there's an emphasis on making sure that there's artistic representations and thoughts associated with these expeditions to the seafloor. Very, very cool. Ken, tell us more about some of these other incredible robots that we've got on screen here. These are super cool.
So, when we work in the deep ocean, there are lots of limitations. It's far away, it's remote, there's a very high pressure from the overlying water column. And to make the most of our observations, we employ a whole bunch of different tools. And usually we do what are called nested studies, where we make observations from the sea surface using surface ships. We make maps of the area using sonar. Sometimes we take camera pictures. If you look in the lower left-hand corner, or excuse me, right-hand corner of this slide, you'll see a camera system that's also a Woods Hole operated system that we can tow behind the ship, and it's got strobe lights. And we take photographic images of the seabed. On the bottom left and center are 2 autonomous robots. They're called AUVs, which stands for Autonomous Underwater Vehicles. They're just like drones that fly in the sky, but these are devices that fly in the ocean very close to the seabed. We give them pre-programmed pathways, and they can do a series of different observations. One of them is make sonar observations really close to the seabed. They give us really detailed views of the features on the seabed. We also have chemical sensors, so as we drive through the water, we can detect, for instance, chemical plumes that are coming off the seabed in volcanic areas, and we can take photographs. So by a combination of activities, we deploy various things from surface ships, we deploy various robots, we can also take samples of the seafloor by various devices. Then we might bring in a remotely operated vehicle to cover a wide area, and after all that is done, we come back with the Alvin submersible, where we've picked specific places that we want to go, and then we will dive there. And oftentimes this happens over multiple expeditions. Many years go into planning this kind of work so that at the end of it, we have a really good idea of the features at a particular site.
So we have a bunch of students joining us both on YouTube and live. And so you get to do cutting edge science in one of the most iconic research vessels of all time on this amazing ship with a group of people from all over the world. And you're a super enthusiastic guy with great hair. If we've got kids that want to be you, how do they go about doing that? Like what's the pathway if kids want to end up in a role like yours?
Well, I can't stress enough that we need as many ocean explorers as we can find. There's plenty of room. Every student out there who's listening to this, please consider this as your career. There are a lot of different ways to study the ocean. And, part of it comes from having a grounding in the sciences. Most of the people who are out here on the ship are either trained as a chemist or a biologist or a geologist. There are, of course, other ways to study the oceans. We have artists here at sea. And so bringing some kind of expertise and mixing that with a passion for the ocean, and then willing to spend some time out on a ship and to learn about all the technology that we use, the practical aspects of, for instance, how do the submarine robots work? How does the submarine work? How do we make the most out of those tools? It comes from a combination of studying and then coming out and getting the experience. And so we're always interested in training the next generation. We currently have out here a large number of what we call early career scientists who are just learning about the vehicles, learning how to use them. I'm very honored to be part of the group that's helping train those new users. And in particular, in my pathway, I studied chemistry and physics and biology all throughout my public education. And as soon as I went to college, I decided, I would like to study chemistry. And I studied chemistry as an undergraduate student. I became interested in volcanoes. I became interested in the ocean by taking classes. And then I went on to what's called graduate school and got my postgraduate degrees, where I focused on studying submarine volcanoes, which is the topic that's on the screen right now, and got myself on research expeditions and learned as much as I could by learning from others, especially about the technology and how we best use it in the ocean. And over time, I managed to become an expert in this area. And like I say, it's something that starts with a passion and a willingness to participate out in the field and enjoy this environment. And the more the merrier.
Fantastic. Before you dive in with submarine volcanoes, I did just want to note how important it is, I think, for students to take away this idea of scientists mentoring young scientists and coming up and early career researchers having these opportunities that you're describing. This is something that I've always loved about the scientific enterprise, and particularly on expeditions such as yours. And so I'm so thankful that you mentioned that and are so keen on that aspect of it. But do dive in. I'm excited to dive in with submarine volcanoes. It's one of the great two-word phrases in the English language. So take us away, Ken.
Well, so this is something that I've been studying as a focus of my personal career, as not just submarine volcanoes, but submarine volcanoes that are actively erupting. There's only a handful of us in the world that work on this topic, even though it's super exciting. It's something that is very difficult for us to detect submarine eruptions, much more difficult than eruptions on land. And so there's a relatively small number of us who are keyed into the various sorts of observations and the observational platforms that allow us to take these assets to locations where eruptions have been detected. Oftentimes, submarine eruptions are detected by accident. And one good example is a place in Tonga that I've been working. It's called West Mata Volcano. And in fact, it's the only volcano in the deep sea where we've been able to see an active submarine eruption, where glowing hot lava is flowing across the seafloor, and where we're seeing large explosive eruptive deposits taking place. And the best example of that happened back in 2009. But I've gone back to this volcano 10 times in the last 15 years or so. And every time we go there, we find that another eruption has happened. So it's a very dynamic place. You're looking at some pictures of different kinds of eruption deposits that occur there. and different ways we sample them. Those kind of claw-like thing that you see in the upper left and in the center, that's the arm of the manipulator of the submarine that's controlled by a pilot. He's or she is reaching out and grabbing the rock and ripping it off the seabed and putting it into we call it the sample basket. It's really a bunch of plastic baskets connected to a skid, which is a large flat platform that sticks out in front of the submarine. You can also see in the bottom left, we've got the arm is holding a scoop bag. It has the number 2 on it. And what it really is a metal frame connected to a canvas bag. And we drag it along the seabed and pick up volcanic fragments. And that picture on the lower right is basically something that's called a pillow lava. When lava erupts in the deep ocean, the coolness of the seawater, along with the relative rate at which lava comes out of the ground, causes it to oftentimes make this tubular form where it chills on the outside, but it's still molten on the inside. And this is a frozen piece of a lava that started to form, it cracked away, and then spilled out and made another pillow lava form that then cracked and spilled out. It's sort of like Russian Matryoshka dolls. And this is a type of volcanism that occurs at many submarine volcanoes. I just have a couple pictures here of some activity. This is, again, I was very honored to be part of this expedition as the lead geologist. This is the only time we've been able to get right up close to an active submarine volcano. This happens at about 1,200 meters depth. So it's a lot less deep than we're working on this particular expedition. But, we'll go wherever the eruptions are. This is another picture of that active eruption. What you're looking at here is hot gases coming out of the volcano. So the gases themselves are glowing, and they push apart little fragments of rock. And then as the eruption continues, it spits rock up into the water, which then rains back down onto the surrounding seabed. And this is some more pictures of this dramatic. This is a time series off on the left. There's 4 pictures there, and each one of those is only 1/10 of a second apart. So what happens is a hot ball of gas that's covered with molten magma spits out from the volcanic vent, and it starts to expand. It's like a balloon blowing up. And as it expands, it also cools, and then it cools and it cracks, and it spits up a lot of volcanic gases into the water. But because the water is very cold, it condenses the gases, and that's why you see that sort of cloud. That cloud is probably actually white, but it appears blue in these pictures because in certain wavelengths of light don't pass through the water very well, and so it tends to give things a bluish tone. Hues of red and yellow especially don't transmit through the ocean very well, but you can still see the glowing hot magma. And this is a process that if this were happening on land, we wouldn't be able to walk right up and see it, because the violent motion of the volcanic fragments as it explodes would make it too dangerous for us to get this close. Where we're taking these pictures from is about 40 or 50 feet away. But because, in addition, there's very high pressure from water when we're under the ocean, because water is also something we call a viscous medium. It's very thick and dense compared to air. It slows down the velocity of the volcanic fragments. So we can actually get relatively close to an active volcanic vent when it's in a submarine setting, much closer than we could get to a volcano on land, such as Kilauea Volcano, which is in my home state of Hawaii.
Yeah. You preempted my question, Wolf, and I appreciate that very, very much. Before you dive in with this next bit, I want to see if we can get a question from Mr. Laveau's class. If you guys want to unmute your mics in North Palm Beach, come on up, take your time, take a second, and we'd love to hear from you guys. Hey, Mr. Laveau.
Hey there.
You got your second device on. Two devices on. Let me get rid of the other one, and then we should be good. How about now?
Sounds better.
There you go.
Awesome. Well, again, this is our first day. This is our first day here at school, so we've got some first day shyness. But I've got some questions that they've written. Merlene wants to know, how long does it take Alvin to dive to its deepest depth?
Yeah, great question, Merlene.
And then Kenny wants to know, how long is this current expedition going to last?
Beautiful questions. Thank you so much.
Yeah, those are both great questions. So the length of time it takes for Alvin to get to the bottom of the ocean depends on how deep it is. On our deepest dives, which are over 6,000 meters, it's taking about 2.5 hours of just sinking down through the water column to reach the bottom. We've added more weight to the vehicle to help make it sink more quickly. And then we have maybe 3 or 4 hours to work on the bottom. And then we drop those weights. We leave them behind on the seabed. And then we gently float back up to the surface. And that also takes a few hours. When we're working more shallow, then we spend less time sinking and rising back up from the seabed and more time on the bottom. But most of the dives, either way, are planned to go in the water at 8 in the morning and then to be back up on the ship at maybe 5 or 5:30 in the afternoon. So that's the length of time we're spending. And depending on how deep we are, we have either more or less time on the seabed. And I'm sorry, I forgot, what was the other question? I
Yeah,
apologize.
it was how long this expedition cycle is. Like, how long are you guys at sea in general?
Oh, how long are we sea? Yeah. So this entire expedition is almost a month long. We had a little more than a week off of Puerto Rico, and then we exchanged some of the science crew in Puerto Rico, and then we came over to the Western Caribbean to a place called Mid-Cayman Spreading Center. It's near the Cayman Islands. And we're going to be here roughly 2 weeks, and then we'll be transiting back up to Florida, and we'll be coming in to Tampa. And the whole expedition is about a month.
Very, very cool. A quick follow-up for Mr. Lavone, so I'll bring them back in. Hey, guys, what's the follow-up?
When you mentioned that about it's going to be 8 or 9 hours out on your day, we had a couple people want to know about snacks. Are you allowed to bring pretzels and stuff on the sub?
Yes, we are allowed to bring snacks. There's always a sandwich. There's a container, a thermos of coffee and a thermos of water. There's a couple of limitations, one of which is that it's a very oxygen-rich atmosphere in the submarine. So they don't like us to wear anything on our skin that's oily or to bring foods that are oily. They also don't want us having either sticky fingers or oily fingers, because we'll be touching switches and controls, and they don't want to get that messy. So we're kind of limited to bring foods that aren't messy. Also, it's really easy. The sub is very tight and compact. And one of the things that happens to me a lot in the submarine is I drop things and then they fall down into nooks and crannies. And for instance, a pen. I've brought M&Ms into the sub before, and then I end up losing most of them down in the cushions, which also creates a lot of problem for the pilots. So they like us to bring pieces of food that are big and won't get lost and don't make a mess. But other than that, you can pretty much bring what you want. And the other thing I should note about being in the submarine is that it is very cold on the seafloor. The temperature in the water is almost the freezing point, and the sub is made out of metal, and so there's really no insulation. And when we drop down from the surface, it only takes about 15 or 20 minutes for the temperature to get very cold. It doesn't get down to freezing, but it can be, 45 or 50 degrees in the submarine. So we bring a lot of clothes with us: thermal underwear, sweaters, socks, caps. And as we're descending down onto the seabed, and then as you're spending time down there, most of us tend to get cold. So we're sort of putting on more and more clothes. And then at the end of the day, as we're coming back up through the water, oftentimes the extra layers will come off, so that by the time we're being recovered, we're back down to just wearing what we took into the sub when we first got in.
What a fantastic answer. And as someone who really wants to end up as one of the observers in the future, it's really good to know, as a master of the 5-second rule in my life and an epic dropper of food, that dropping a bunch of M&Ms in the chair does not disqualify you from getting invited back. That's really good to hear, Ken. So thank you for that.
Yes.
You've got this beautiful picture all queued up for us with pyroclastics and the Prometheus vent. You guys are good on these epic names on the expedition, so tell us more.
But so this happens to be a picture of an explosive phase of a volcanic eruption. It's sometimes when there are different styles of activity, and sometimes when seawater entrains into the crust, it's a process that's actually sucking water down into the rock, and it mixes with the molten material in the subsurface, and it causes an explosive fragmentation. That's what we call pyroclastics. And so what you're looking at here, I have an arrow kind of showing water being sucked in, but as it's being sucked in, it flashes to steam, and it causes the rock to fragment. And so glowing hot pieces of rock are spitting back out into the water. And again, the submarine's only about 20 feet away from this happening here. And this was a pretty amazing thing to see. We know this process happens on land, but we had no idea if it would happen under the ocean. But in this case, it did. And this makes a different kind of rock deposit on the seabed. Instead of making lava flows, it makes thick blankets of a material we call tephra, which are little pieces of volcanic rock that pile up like a coarse sediment. And this is what it looks like after it cools. I don't know if this image might be a little bit dark, but you can see sort of a mound of fragments, and then there's a couple of sort of roundish rocks sticking through. Those roundish rocks are lava, this so-called pillow lava, and then fragments of these glowing hot pyroclasts spit up into the water, and then they fall back down to the seabed, and they make these mountains of tephra that cover over the lava. And I have a couple pictures here showing you how we sample that stuff if you're interested. So the one thing we like to know is, well, how deep is the tephra? So this is a picture of an ROV handle. This happens to be from the ROV Sebastian, which is a Schmidt Ocean Institute vehicle. And that's a metal rod where I've taped on little bits of red tape. Each line of tape is 10 centimeters. And for those of you who don't exactly remember the metric system, they're 2.5 centimeters per inch, right? So those are about 4 inches apart. And we take this rod and we stick it down in the sediment. We figure out how deep it is. And depending how deep the sediment is, the volcanic tephra, we can use a couple of different tools. One tool we have is a long tube that we stick in, and then we sample what we call a core. And that works when the tephra is thick. When it isn't too thick, we take a scoop. So I have a couple pictures of those things here. This is a push core being pushed into the sediment. So there's a sequence that goes from left to right of this tube being pushed in by the pilot. That's a manipulator arm holding the tube. And then it's being pulled out there on the right. And you can see the volcanic grains in there. They're very dark and black. This is a zoom in photo of that. And this is what that looks like when we bring it back up onto the ship. It's like a coarse sand, but the difference is that all the pieces of rock are very, very shiny and they're very sharp. There's something called volcanic glass, because when lava freezes very, very quickly in the ocean, instead of making something that looks more like a rock that you would find in your yard, it makes a clear, translucent material that's very, very jagged on the edges, which is equivalent to the window glass in your window frame, except that because it's got other chemicals in it, it shows up as dark. This is another picture of us using what's called a scoop bag, or dragging a bag along the seabed, again, using that arm on the manipulator. And this is what it looks like after we've dragged that scoop bag through the sediment, and we bring it up on the ship, and it looks basically the same. This is a scientist emptying out a bag. We get a big pile of material, which we dry and then look at under a microscope, and we analyze it chemically, and we analyze the shapes of the particles, because they tell us things about how the particles were formed and how they were transported along on the seabed to form the deposit that you see. And so that's basically what we do when we're studying the various kinds of volcanic materials. And this is a zoom in. You can see I put a 1 centimeter scale bar on there, again, showing these shiny little fragments. If you touch them with your hand, you can actually get little pieces of glass into your finger. So normally we're using gloves, we're using tweezers, we're handling the materials very carefully.
This is so...
I just have a couple more volcano pictures, and then I hope to talk to you all about some hydrothermal vents. These are some pillow lavas in place on a very, very steep slope. It's hard to get the scale of it, but those in the right-hand picture, you're looking at something that's about 30 feet high, and each one of those long cylindrical tubes of lava was something that's spilled out. They actually flow relatively slowly from the top of the picture to the bottom, and they freeze on their exterior, but because of gravity, they keep kind of dropping out as if you were sort of dripping honey out of a honeybee container. And as they drop down, they freeze and they elongate, and then another one is formed right next to the first one. And they make these mountains that almost look like silly putty, for those of you who know what that looks like.
Just stunning. I mean,
and that was the last lava picture, and I'm happy to answer more questions, or we can move on and look at some hydrothermal chimneys and hydrothermal vents and hydrothermal vent biology.
Well, I'm just one really quick question. One of our classes had to go. I know it's the end of the school day there, and so if people on YouTube do have any additional questions, please do share. My biggest one with those, like, just such beautiful pictures you just shared. Every time you go to a volcanic vent, are there things like that? Is that fairly unique? Was that like a big special day when you're going down, or is that like commonplace? Any undersea volcano has amazing things like that.
Well, let me just say that every day I get to go down is a special day, and it never becomes less special. I feel very privileged to be able to go to these places, and sometimes it's awesome because not only are you very deep under the ocean, you're very remote, and it's possible that you're visiting a place that no human has ever seen and no human will ever see again. So it's it's really, really an amazing experience. The kinds of features that you're seeing here, I wouldn't call them common, but they're not unique to an individual spot. So the individual lava forms that we find depend a lot on the conditions at the particular volcano, not only sort of how deep or how shallow, but what is the magma made of? How fast does it come out of the volcanic vent? At this particular place that you're looking at, the magma actually has a lot of crystal in it, large grains of that we call phenocryst. And this makes the magma a little bit more viscous. It makes it flow a little bit more slowly. So it helps contribute to these very elongated rocks. So in this particular place, the rocks are sort of longer tubes than we find in other places. But this general form of pillow lavas is actually pretty common in the oceans.
Okay, very, very cool. Thank you for the detailed answer. And now I think we've got to go to these hydrothermal vents because they are just the most extraordinary things, I think, in the entire deep ocean. I mean, it's a really incredible place, broadly speaking, but these are just such a special ecosystem and fairly new to science as well, all things considered.
Yeah, hydrothermal vents are one of the most amazing and awe-inspiring features that I've ever seen. They were discovered in the late 1970s, and in the ensuing decades, we found more places where they occur, and there are commonalities between all of the places, but there are also a lot of unique features of the different sites. And the thing that drives hydrothermal activity is hot water interacting with rock in the deep subsurface, so beneath the seabed, dissolving chemicals out and exchanging chemistry between this deep subsurface back out into the ocean. And one of the things that these fluids have is a characteristic that we call chemically reduced. It doesn't really matter what that means other than to say it provides a form of energy that supports life that is equivalent to, but different from, the kind of energy that the sun provides to surface plants. In both cases, this form of energy allows plants to convert carbon, like carbon dioxide, into organic molecules that then other animals can live on. In the deep subsurface, there's no life, but these hot fluids with these chemical reduced properties allow various microorganisms, primarily bacteria, to also
Oh, we've frozen with Ken. This is the challenge of being out on a deep sea expedition sometimes. We'll see if we can get it back. Maybe the hydrothermal organisms
that
didn't want to
come
go.
out
Oh, there we
process
go.
we call precipitation. So people call it smoke. It's not really smoke, but this is a black smoker. And I named this particular vent field in Tonga the Temple of Smoke. And the material that's sort of whitish and purplish are little solid vertical structures that form from the same black smoke material that's continually growing, slowly reaching up ever higher above the seabed. And then animals live on top of them. In this particular case, in the foreground, we have some shrimp and some worms. And in the background, you'll see some other spires that have this sort of flowery looking material. And I have a close-up of it coming up on the next slide. But those are barnacles. They're called stalked barnacles. They're connected to the seabed, but they have a plume that they stick up into the water. And they actually gather their food from the water. And they are living off of microorganisms that are themselves being fed by that black smoke that's issuing out into the water. These are some other hydrothermal chimneys at another volcanic vent field. They look a little bit different. Each one of those spires that you're seeing here is about 3 or 4 feet high and somewhere between about 6 inches and a foot in diameter. You can see some crabs hanging out on there. There's also some long white things. Those are shrimp. There's also some worms. They're a type of worm that we call polychaetes. I don't know if you can, I can't point with my mouse, but in the left-hand side of the image, you'll see some white spires. And if you look down, about halfway from the white spires in the middle, you'll see a couple of pink things. Those are called Polychaete worms. This is another set of spires at another volcano in Tonga. And in this case, it's covered with shrimps. Those are those circular features that you see clustering together in the lower right-hand corner. You also see some crabs around them. And then you'll also see some shrimp. And the one thing that you might notice is that all of those snails are focused in on the part of that chimney structure, which is white. And the part that is orange doesn't have the snails on it. And these animals are very particular in the type of what we call microenvironment they like to live in. And so they choose the part of the chimney structure that has the right temperature conditions and the right fluid chemistry for them to thrive. And so it turns out that in this particular picture, the darker areas are no longer venting fluid. They're sort of older and colder. And so the animals aren't sitting there. They choose to go into that whiter material where there's hot fluid coming out. This is a close-up of some of these stalked barnacles at the base of a large hydrothermal chimney. This picture is about 30 feet across, and there are literally thousands of these barnacles clustered together. And in and amongst the barnacles, you will also see, especially in the sort of bottom center of the picture, some crabs. These are actually something that we call galatheids. They're sometimes referred to as squat lobsters. If you focus in the upper right-hand corner of the image, you just move in about a quarter of the way from the right, you'll see a fish. That's a zoroacid fish. They live in these hot vent fluids too. And if we had time to zoom in on this, you'd see all sorts of other animals living in and amongst those barnacles. And now I just want to, unless anyone has questions, spend a little bit of time showing you how we take samples at hydrothermal vents using the submersible. And these are both a series of slides and images taken from our dive yesterday, which I wasn't on, but other people here on the ship participated in.
Fantastic. No questions coming in yet, so feel free to take us in with that. We've got about 15 minutes left. I want to make sure that we get the chance to feature some of the art on the expedition as well, but we'd love to hear a little bit about the biological sampling, so take us away.
Great. All right. So this is a sequence of, this is another chimney structure at a site called Von Dam. This was a site that was discovered about 10 years ago, and it's named for someone, her name is Karen Von Dam. She is one of the people who studied hydrothermal vents over most of the last half of last century. She passed away about 10 years ago, but she contributed a great amount of knowledge to us about the chemistry of hydrothermal chimneys and the fluids they emit and the processes that happen in the subsurface. And so other scientists who discovered this site named it after her. And you're looking at the upper third of a large hydrothermal chimney, and you can see some black material. That is the sulfide minerals of the chimney. And all that white stuff is actually living shrimp. There are thousands of shrimp in this picture. I'm going to show you a zoom in where that square is. And you can maybe start to get an idea of all of the shrimp that are living there. And the way we sample those shrimp, as soon as we bring a manipulator or a probe or anything, they all start to swim away and swarm. And so this is a device called a slurp sampler. And that blue hose is connected to a pump on the vehicle. It's like a vacuum cleaner, but it's sucking water instead of sucking air. And you can see in the sort of left-hand side, a claw. That is the manipulator arm of the vehicle being controlled by the pilot. So the pilot is just positioning that in front of these shrimp, and he's going to turn on the pump, and we're going to suck some shrimp, and the shrimp will move through that tube, and they will go into a series of plastic chambers. And then those plastic chambers are sealed, they're brought back up to the surface, and then the scientists take out the shrimp and they study them. And so I have a couple pictures of that as well. This is a video showing shrimp.
See, I'd just be standing there with my jaw agape, just staring at these creatures from the bottom of the ocean. Very chill people on the ship.
Yeah, so this is a picture of the submarine after it's been recovered. It's back on the ship, and it has a little garage that it sits in that we call the hangar. And after the vehicle is secured and all the power is turned off and all the dangerous parts are sort of put out of the way, scientists are allowed to come in and start taking samples off of it. And so this slurp sampler is opened up and each of these chambers is removed. And this particular dive, we had different animals in different chambers. And I'm just showing you the shrimp. I'd like to show you what happens to them next is they get taken into a cold room. And this room is very cold in there. It's about 40 degrees Fahrenheit, just a little bit above freezing. It's meant to simulate the conditions that we find on the deep ocean. And there the scientists will continue to work to do their initial examinations of these shrimp. So this is a picture of that tube of shrimp now sitting in the cold room. And a scientist from Woods Hole named Tim Shank is taking this out. And you can see there's hundreds of shrimp in that tube. And I've got a couple of short video clips showing what he does next, which is basically he takes every single shrimp out and he weighs it and he measures the length and he takes a picture with his camera and he looks at various features of the shrimp to identify what species of shrimp it is. Is it a male or is it a female? Is it young? Is it old? And he compiles this information and uses the sort of variation of all of those parameters to say something about the shrimp population. And of course, there's other animals that are collected as well, and they're looking at all of these things together. So this is a picture of him doing his work. He you know, this sort of the confluence of modern conveniences with science. He's using his iPhone and taking a picture of a shrimp that is sitting next to a ruler. And I have a close-up of that activity on the next slide. So there's a shrimp on the table and there's his phone. He's taking a picture of it.
What a freaky cool thing that
So,
guy.
you know, you look at these features, the kinds of animals that we see down at these hydrothermal vents, and some of them are not too unfamiliar. Things like shrimp, we all know shrimp. You know, they look a little bit different at the deep sea vents, and there are a variety of forms, but they're fairly recognizable. There are also fish that we find in these settings, but there are also some very unusual animals that we find only in these settings. And I would like to give you a brief tour now of some of these. They're called hydrothermal tube worms. So these are tube worms on the seabed. This is a zoomed out view. The worms are those long white features. And in fact, most of these worms live in a hard shell tube that they make. And the worm itself is a soft, almost slimy organism that most of its body lives within that tube, but it has a small little plume that it sticks out into the water, and it can filter food from the water column that is being fed by the water that comes out of the hydrothermal system. This happens to be at a site that we call diffuse flow. So instead of seeing one of these hydrothermal chimneys and the black smoke coming out, instead there's warm water here percolating out between all those rocks, and there's just enough of these unique chemicals in them for these tube worms to thrive here. There aren't a huge population of them in this site, but there's enough of them to allow us to study them. This is another slightly more zoomed in picture. That's the front of the Alvin submarine. And these particular worms, we can't sample with that suction sampler. Instead, what's going to happen is that the manipulator is going to pick up an entire rock upon which these tube worms are connected, bring the whole rock with the worms back up to the surface, and they stick it in one of these black boxes that you see in the bottom center of the diagram. These are boxes that are filled with water that have a lid. We open the lid, the pilot sticks the rock in, he closes the lid back down, and then the vehicle gets brought back up onto the ship, and then we open the box again, and lo and behold, our tube worms arrive at the surface. This is what those same tube worms look like. So that is the entire rock with the worms connected to it, sitting in front of the vehicle. Right. And I'll just show you one more picture of those worms. This is a close-up I took with my phone. And so you can see a combination of things here. You can see the tubes. You can see on the right-hand side, there's a tube that no longer has a worm in it. That's like a hard shell, an elongated feature. And you can also see lots of the root of the worm tube. So basically, those are those sort of stringy things. Some of them have been a little bit disrupted by the sampling, but it's a hold fast. It allows the worm to basically stay in place. So it's got its tube. It's got a thing that's kind of like a root that it sends down into the rock that allows it to sort of stay in place. And then there's the worm itself. We don't see any of the worms sticking out of their tubes here. I think because they've been sampled and brought to the sea surface, they're maybe a little bit shy, and they don't have their plumes out. But these tube worms were then brought into the lab, and again, each one is taken out and investigated. It's quite a tedious process for the biologists because every organism that we take from the seabed gets investigated. Yesterday, we also sampled some hydrothermal fish. I didn't show you any pictures of it, but another scientist on the ship, her name is Mackenzie, dissected the fish, and she was interested in taking out the liver of the fish. And these fish are pretty small. They're, maybe 7 or 8 inches long. So the liver is, maybe the size of your thumbnail. And she takes those out and she examines them chemically and physiologically to see something about the health status of those particular fish. So that's hydrothermal stuff. If we want to cut it off here, or you guys want to ask me some questions, we can. I also have some images about how we use submarine robots to map the seabed in detail, but we don't have to go through that if you'd rather just ask some questions.
I think for the purposes of time, and we do want to make sure we chat with Karen just a little bit as well on this. I know we could talk all day. I could talk to you for 4 straight hours. In fact, we could do an entire Alvin dive in the amount of time that I could talk to you about the stuff that you discover on these expeditions. But I will defer to the website if people want to find out more, check out more about the deep sea mapping, how the robots are used, all the other stuff that we could do, and many more broadcasts in the future, by the way. We'll welcome you guys back anytime. You're welcome as the flowers in May. We love to feature Alvin in your expedition. But I did want to highlight again how this all came together, the opportunity that we have to showcase this, and that is through the lovely woman sitting beside you, Karen, whose name's on the bottom of our broadcast here. So a big hello to Karen for her amazing work with I Was a Kid. And so I know she's featured you through her artistic platform. There we go. You have to take your time and switch it over. Hello, Karen.
Hi, Jesse.
Hi, I'm just bringing up stuff for everyone. I mean, we could talk to Ken all day, and we kind of want to, but we are running out of time in the broadcast, and I did want to feature some of the stuff that you've done to feature the scientists, both with Ken and with some of the other scientists on the ship. So iwasaKid.com is this incredible artistic project to highlight scientists, career paths, all sorts of great stuff going on with that. Could you explain a little bit about the origin of this and how you've had the chance to sort of dive in with it on the ship?
Yeah, I Was a Kid is a program that I've started that's centered on comics about people working in STEAM careers. And I think that it's really hard for kids to sometimes understand, how do I get from being a kid who's really interested in volcanoes to being somebody like Ken Rubin, who is working on a ship in the middle of the ocean and diving in Alvin. And I think that it's hard. It's easy to say, I could never do that. I don't have any idea how to get from here where I am to there where he is. And so to be able to talk to people working in these cool fields and say, what did you do to get where you are? And was it a smooth trail, or did you have some rocks along the way? Ken's had a lot of rocks along the way. But the other kind of rocks, obstructions and problems and failing tests and, missing things, or, all those things that we all go through, the humans all go through. But sometimes it's easy to think that people who are working in these situations are, superhuman somehow, and have superpowers that allow them to get to do these things. And so what I'm trying to do through I Was a Kid is to really show what their lives are actually like, and to get some advice from them for kids about, if you think that this is a cool thing to do, here's how you can do it. So it's comics based, but it also has audio clips. There are, connections to video, like Exploring by the Seat of Your Pants, and a signpost that talks about, little crooked corners along the way that people went through and how they solved their problems.
Well, it's a beautiful project. We've been thrilled to feature some of the scientists that you've had talked to over the last couple of years. And especially we want to thank you for this opportunity to go on the expedition. Your work is really prominently featured on that website that we've highlighted a few times now. So if people want to check out the Alvin 6500 expedition, check it out on Twitter with hashtag Alvin 6500. You'll see some of the things that you've done with people on board the ship. And I really just can't highlight enough what a beautiful program it is. So iwasakid.com, at I Was a Kid Steam, and if you want to learn more about your broader work and sort of the way in which you go about showcasing these stories in such a beautiful way, your personal website is now on the screen for anyone to check out as well. And so, Karen, how did your path get you on the ship? Was it just featuring some scientists and getting involved? I know the Woods Hole Oceanographic team has been sharing in the YouTube chat a bit about how artists end up on board the vessel, but what was your personal path?
My personal path was that I was working on a book about navigation, and the book compared animals and people. So there might be a sea turtle migrating across the ocean, or people crossing the ocean on a container ship, but the animals were all migrating. And when I was talking to a scientist, they said, did you know that there's something called a vertical migration, which is something that happens every single night, every single day, where things that are at the surface sink down to the bottom, and then they come up the next day? And I said, well, that's fantastic. I've never heard of such a thing, but I really need there to be a vehicle, a human vehicle of some kind that does the same thing, because that's how the book is set up. And someone said, well, you need Alvin. So I called Woods Hole and I said, who can I talk to about Alvin? And they sent me to a scientist who was working with Alvin. And I worked with him, and I wound up getting invited to come to sea to do some of his education and outreach like this, where we are on the ship or in the submarine talking to kids and anybody back on shore.
Oh, how outstanding is that? And by the way, thank you so much for featuring the vertical migration. This is something that we've done like 3,000 broadcasts, and maybe this has been brought up twice. But I think so many people think about migrations. They think about caribou or monarch butterflies. And the biggest ecosystem, the biggest area for life on this planet is the oceans by a huge margin. And so the thought of these trillions of animals really that come up and go down every day to follow the sun and avoid predators is so, so special. So thank you for highlighting that as well.
It's one of my favorite things too. I'm glad you like it.
Absolutely. Well, Karen, Ken, I'll bring you both back in on the frame together for a second, even if only one of you can hear me. I just want to say a big thank you so much for the opportunity today to chat with you both, to feature all these great stories. Again, we've been featuring this website a lot, but I'll make sure people have it to check out. And again, this is all part of the Woods Hole Oceanographic Institution's incredible work to educate the public. And this whole expedition has been made possible by the incredible National Science Foundation team. So all of those are looped together. We want to make sure people have the opportunity to check out how this science gets funded, how these incredible opportunities come to life. And so I want to say a big thank you to you two for helping share that with us today. So I really, really appreciate it.
Thank you, Jesse. It's been a pleasure.
Pleasure, guys. Thank you to our big audience today from all across Canada and the US. We'll end our broadcast there and have a wonderful rest of the day.